Hello, hi everyone. So today, what we're going to share is basically our lesson 5. You just turn on. All right, lesson 5 is our module 9 on sanitary pumping and of course systems. So let me just turn on this. All right. So for sanitary and pumping, just give me a second. Yeah. So, you just give me a second. Yeah. Something is okay. Yeah. So for sanitary and pumping, this will be the topic, right? Our learning objective is basically after doing this subject, right? Students will be able to describe the difference between sanitary and systems, identify some common sanitary applicants, and identify the components of sanitary pumping system, and actually explain some of the traps, then describe the features of application on single stack and ventilator stack system, right? Explaining the advantage and disadvantage of the different piping, identify some components of the sanitary system, and describe design requirement for sanitary systems in the drain line inspection, and also need to describe the operation of a grease trap, sewage ejector, and etc. So this introduction is about carrying out sewage systems quickly, and then we can be kind of either above ground or underground. Sewage systems also carries wastewater in the sewage, and then treatments, plant in the reclaim kind of reclaim plants. So with that, authorities, it has some authorities jurisdiction. So sanitary pump, there's wastewater coming in from above ground. The sanitary pumping, wastewater also coming from somewhere at the ground. Underground is the sanitary system, and then goes to a sewage system. So with that, the deep tunnel of the sewage system, or DTSS, right? You can see that there are deep tunnel system within Singapore that is kind of drilled inside. Yeah, so there's three long main line, right? Which is a deep tunnel used to centralize our water reclaim plant. Okay, and through this, right, you actually purify into utter clean, and then it can kind of discharge to the sea if there's an outfall. So sanitary system, let's talk about it. Those are like straight pipes. You can see all this right in your HDB flat. And there's also like manholes. So these are some of the ventilation traps. So with that, there's some wash basin that is usually see. And then with wash basin, right, water gets lower and then discharge, right? And with that discharge, right, there's also what they call that gas or area that can actually goes up, right? So common sanitary apparatus are like washing basin, sink, shower, urinal, closets, etc. Closet can be a pedestal type, or it can be a wall hang, or there's also beaded, right? It's a little bit more atas type. So characteristics and the applied materials. These are basically more of a durable, corrosion resistance or non-porous, is easily clean. Yeah, you can see that these are some of the materials inside. The hand showers are here, and then some are tempered glass or stainless steel, etc. So sanitary pumping system, there is discharge pipe, right? There's a ventilation pipe, ventilation stacks and fittings around. And discharge pipe are some of the methodology, discharge stack, ventilation pipe, ventilation stack, wastewater pipe, and sanitary appliances. So a pipe that enables sewage or water converted into sanitary appliances on the floor, mean vertical pipe that extends through the storage with or without offset, and a pipe provided with limited pressure fluctuation without any discharge. So it's also a main ventilation pipe that extends through at least one story or without offset. So a pipe that contains any wash basin, right, like for waste pipe, and it has actually 4 traps or unitary traps. Yeah. So basin and bathtub are also they are part of the sanitary appliances. So with that, you can see that sometimes on your HDB flat, right, you can see there's a pipe here. So those are actually open to atmosphere. It's called a ventilating stacks. So with that, let's take a look at your water closet. Whatever waste you go through, right, and then goes to the drain. So while it goes to the drain, sometimes you will see an S trap. Right? S trap is something like that. Sometimes you see a straight line trap, it goes to a S trap, then goes down. Yeah. So the design layout of sanitary systems, sanitary pumping system is designed minimum work so that it can carry away. You do not create any nuisance or health risks or damage to the building. You prevent entry of glass into the building through the sewage. That is through the S pipe. So it doesn't carry any rainwater. So some key consideration to look at will be the size of discharge pipe and discharge stacks, the slope of the discharge pipe, provisions of the trap, right? And the size of the vent pipe and ventilation stacks, and choice of material, connecting discharge point and vent pipes and maintenance. So the position of pipe placed, right, above potable water, electrical transformer from a swimming pool to their balancing tank. And in all multi-story residential, right, there's no pipe. It can be adjacent to the dwell system. Then from WC, right, your wash closet within the kitchen, or it can be from a kitchen sink. So for non-residential building, no pipes from the WC in the ceiling is a commercial unit. No discharge start or overhead sanitary is sited within the food establishment where food is cooked, prepared, or stored and served. So all sanitary appliances are connected to a pipe by a trap. U-tube holding a column of water by preventing entry of fall gas into the system accessible for cleaning. So design trap will be an integrated trap, a P trap, S trap, or bottle trap. Okay, integral trap is like it's integrated, right? So you can see this water closet, water comes in, there's a depth, and it's kind of integrated so that outgas shouldn't be able to come in, right? So this is how it actually looks like. So the section of it is kind of integrated. Yeah, so it's called an integrated trap. Integral trap, sorry. P trap and S trap. P trap is like a letter P. S trap is very similar. You can see that there's like an S shape. P trap is like coming down this way. So there's a depth, and then it kind of hold the water inside so that when water goes in, it can be discharged out, but outgas that comes in is kind of trapped. So P trap is preferred usually to S trap because there's less likely to lose water, right, in the water seal through a siphon. Yep. So bottle trap is something we always see in the sink. Water goes in, bubble through, then goes out. So outgas from outside when it comes in is a little bit more difficult because it's blocked by the water. Air pressure in the stack, it goes up, discharge comes down, and then of course there should be air coming in, right? So on the left-hand side, it sees like the kind of atmospheric pressure is here, right? So it gets a little bit negative, suction by pressure. So there's discharge, and then it will get discharged this way with some positive pressure. So loss of water seal. So water seal comes in and it goes out, right? But if it's normally about 25 mm water seal, no sewage escape. So this is no sewage escape through the door, but evaporation, water will dry up. If you don't constantly use a building, right, the air will come in and then pollute kind of your building. So loss of water is when when the wastewater travel down, it creates some negative pressure, and then sometimes it gets stuck with the steel of the trap, right? So compression, sometimes over compression, right, will also cause a wastewater to be stacked down and then create positive pressure in front so that the blows steel of the trap. Then high winds create negative pressure and sucks to the trap from the trap. And capillary of action where there's debris, clogs inside also will have some loss. Yeah, so with that, you can see that loss of water trap, water goes in, right? And then there's form of a trap by itself. So this a video that we can show. So sanitary system, there are 3 different types: a single stack, ventilated trap, and a full trap. Single stack will have closely grouped in a discharge, and then there's up to 6 stories building. Ventilated trap are sanitary appliances grouped together in a discharge stack for all building height. Yeah. So single is for 6 story, ventilated is for all building height. Fully ventilated, if there's a very large number of sanitary appliances, then it actually will be able to kind of all disperse in that building height. So with that, single stack actually has air coming like this drawing, right? You can see a drawing. There's this main line, and then besides all this the wash wall basing and stuff like that, water will flow in and then gets into. So this is one of the drawing that we'll talk a little bit more detail later. So no ventilation stack. The stack stacks are large enough to have vapor pressure fluctuation. Then discharge stacks has, if it's 4 stories, it's about 100 mm diameter. If it's above 6 stories, it's about 650 mm in diameter. So the length of each pipe, maximum of the discharge pipe, right, could be about 2.4, and then maximum number of connector could be actually 2. So this is a single stack system. Ventilation stack, as what it says, it actually has a ventilation. So it has some ventilated. So maximum of length is still about 2.5. Number connection is 2, right? And then it kind of go down. And then you can see that, hey, there is something that's standing on top here, right? So very similar, except that there is some ventilated stack. Then there's this secondary discharge stack also, right? It's about 100 mm diameter, usually for the 2nd and 3rd story, correct? So there's sometimes cross ventilation across the different stories. Fully ventilated is, as it means, it actually has a separate ventilation stack, right? Unlike the other one, which is the ventilator stack, there's no additional stack, but full ventilator actually has an additional ventilation stack. It's individual traps, right? Because it provides more water discharge to that, and then the discharge stack is usually about 100 mm. The traps is connected to the discharge pipe, and then it has a branch of a ventilation pipe and a diameter of approximately about 50 mm. So fully ventilation stack shall be constructed upwards individually and be connected to the main, right? Such that the connection be above and spill over in case there's some soil sanitary appliances or the soft trap being trapped. So with that, you can see that these are some of the pipe. This is a P-trap. This is a fire sprinkler. There's a discharge pipe. There's a range of different pipes you can see. So these are some of the drawings for fully ventilated stacks, as you might be able to see. Then the discharge pipe is as below. Yeah, fully ventilation stack at the very top end shall be either be terminated as a high or discharge stack as connected to a discharge stack point about 150 mm above, so it prevents spillage, right? Or soil or topmost soil of the sanitary appliance of the floor track. So usually this is how it will look like. Yes, at the very end of the ventilation set, right? So building with 7-story discharge pipe for 2nd story or connection. 2nd story, there's about 100 mm diameter stack extended to serve the ventilation stack, may be reduced to about 75 mm. So cross ventilation, there's a stack discharge. There's a ventilation stack and the discharge stack, right? So it provides some mid-height building up to 20 stories. So every 10-story floor or taller than 20 stories will have a full ventilated systems. Yeah, so the ventilation system, right, between secondary discharge and the discharge at 1st story, right, should be about 300 mm above ground, right? The lowest, about 250 mm at the lowest point of the discharge connection. So termination, yeah, you can see that there's sometimes a lot of such termination on the stack, right? Just to prevent, air will come out, discharge air will come out from here, and this is how it actually looks like. This can be seen quite often in either HDB flats or etc. So material use is usually UPVC, unplasticized polychloride. or rigid PVC. Sometimes you have cast iron. So advantage is it's light, smooth for boring, easy to do, resistance to corrosions. And then disadvantage, sometimes UPVC can have expansion, and then it's easy for kind of movement, right? So because there's expansion, you need to kind of have some expansion movement, and it's easily destroyed by fire. Cast iron is very strong, mechanically very strong, can stand withstand damage, but it's very heavy. Disadvantage is heavy, it requires protection against corrosion, and sometimes you apply a layer of glutamate inside or outside surfaces. Connection on the sanitary appliances on the first story, usually high risk, right? So sanitary appliances on the ground floor are not connected to the discharge side, but connected directly to the drainage side below. So usually first floor is to below because it's a little more risk of compression. Yeah, this is one of the way you can look at it. So it's like a manhole, water from the trap goes in, or from your wash corset, right, goes in, and then you get discharged through some inspection hole. So sanitary system is underground system comprised of drainage material or drainage line, a branch of drainage line, fitting and inspection for convenience of the sewage. Drainage water is not allowed to be discharged into the sanitary drainage system. So branch, all right. So terminology, some branch drain lines. So connecting the sanitary pump, discharge, and sanitary appliances on the ground. The main line is connecting the inspection chamber. Inspection chamber, of course, provide the access of the drains and inspection and testing and clearing of the blockage. So invert is basically the lowest point of the internal surface, and then surface is the highest point of the internal surface. So inspection chamber, a lot of time you can see that the drain will provide inspection chamber, and then that's where the drains comes in, and the side view, you see there's many branches coming in. And of course, there is a cast cover on top. Further drawing, we can see that, hey, these are the area of the main. The drip pipes actually can go in. Yeah. So inverted soffit, right? Soffit is basically like a section of the drain pipe. You can see that is internal. So lowest point is called invert, highest point is called soffit. Yeah, so this is the two surface, internal surface of the pipe. So water type, right? Pollution of surrounding ground is unhealthy. Entry of rainwater is over, right? If it's over, entry of old water, then you will have some flood challenge. Self-cleansing, sometimes it's breeding of bacteria, so we use either hydrogen sulfate or methane to kind of clean the bacteria. So with that, drain lights has to try to avoid as many bends as possible. Same diameter, same material throughout, that's the best. Constant gradient approximately about more than 0.9 meter per second or less than 20.4 meters per second to avoid scoring, right? So floor trap to receive connection or drain before the discharge, and then it can actually have a drain of kind of discharge in this particular case. All right. So design principle, each drain connected obliquely in the same direction of flow as the main line within the IC. Drain line must have minimum diameter of 100 mm and the length must be less than 10 meter. Drain line, a minimum diameter of 150 mm. So inspection chambers provide some access of drain to inspection, testing, and clearing of the blockage. The located points to be a junction, a change of directions, or the drain line gradient and the change of diameter. So this is a provision for some chambers where you can see that a drain line is coming in, the main drain line is coming here, right? So there's some chambers of inspection chambers that you can see. So from ground to overflow, there could be inspection chamber in between, but that needs to have some gradient, right? Inspection chamber could also be from the main drain line, right? They have an inspection chamber to the discharge, change of a diameter. So there's inspection. So sometimes change of materials also have some inspection, right? So distance between IC is about 50 meters. IC should be ventilated, except there should be some ventilation pipe, right? Sanitary pipe should be ventilated, and then air pressure and of course loss of traps. So there's foul air in the building. So sanitary system could be ventilated to prevent foul gas building up. Bacteria grow and multiply in the air ductless area, and then the production of hydrogen sulfate and methane could actually objectively smell of flammable. So ventilation of sanitary drainage, as you can see, is going down, and then where it builds the first IC or public sewer. So that's how it could actually be looking at. We also have some provision of the grease trap, which has eating establishment, and then it grease directly to the sewage. Right, this is how it can actually look like. So provision of grease trap could be one of the area that you actually will see. This we can see in school, or basically what they call that food court. The grease trap, some people are cleaning, yeah, the drawing of the grease trap. And sewage and wastewater is kind of collected and then usually below ground, right? Yeah. This is the ejector. Ejector is basically you draw out the water and then kind of eject out, and there's some of the sewage ejector we'll see. This is in the car park of Nanyang Poly, right? And yeah, that's how it actually look like. Then there's also some tank with emergency submergible pump, sometimes of the drainage, as you can see here. And then sometimes basically water enter. If there's a set point, then you can flow and then kind of discharge out. Yeah, so basically that is the topic about plumbing and drainage system.